This video is the second video of DP series. In this video, we are going to solve coin change on Leetcode. So without wasting any time, let's directly get into the video.
So we are on our screen right now. This question basically says we have to use a different combination of coins and we have to use minimum number of coins, not the minimum amount from this minimum number of coins to get this amount. For example, in this case, we have to get 11. We can get 11 with just three coins. So how can we do this? The first approach which comes to my mind is exploring all the possibilities, like trying one, then 1, 2, 5, 1, 2, 2, 2, then 1, 5, 5, 5, like this, exploring all the possibilities till we reach this amount. So for exploring all the possibilities, the first thing which comes into my mind is recursion. So let's try to write its recursive solution. Okay, so for exploring all the possibilities, what can I do? I can simply loop through each and every coin and try to use that coin. Uh, let's just use coins name and try to use that coin to get the answer. So I can just create a variable here int mini is equal to int max. Then we'll get the answer from here. Solve coins. I will minus this coin from the amount. If amount reaches 0, this means we have got the coin. If amount is still less than 1, sorry, if amount reaches less than 0, this means we haven't found our coins which will give that amount. So we can add two base cases. If amount is equal to 0, then just simply return 0. Otherwise, if amount is less than equal to 0, then return -1, which means we haven't found. We have to return -1 if we haven't found any combination. So we are just minusing from the amount, and this will call the function again, and then it will loop through all the coins. We'll try to minus each and every coin and see which one fits for the correct answer. Don't worry if you're not able to understand it properly. I'll make you understand it through with the help of recursion tree also. So just wait. So if answer is not equal to -1, then we can update the mini with mini is equal to min of mini, or we can do answer +1. Why I'm doing +1 here? Because we have used this coin. We have got the answer using this coin. That's why I'm doing answer +1 here. Okay. And in the end, we can simply check if the mini is still int max, which means we have got the answer -1. If the answer was not -1, then mini would not have been int max. So if mini is equal to int max, we can simply return -1. Otherwise, we can return mini, which we have got. And then I'll call this function here. Okay, so what we have done, we have got the intuition that we can explore all the possible cases. So we are looping through each and every coin and then calling this function again and again. For example, first from amount we are minusing 1. Then again the function will get called. Then again the loop will start. Then we are again minusing 1, 1, 1 until we reach any of the base cases. And then we'll return. Then inside for loop we'll -2. Then we'll get some of these base cases. Then again we'll do the same. And we'll keep doing it. This way we have explored all the possibilities and we are returning the answer here. So let's try to run it first. As you can see, our code is running successfully, but this will definitely give us a TLE when we'll try to submit it. As you can see, it gave us an TLE. Of course, it will. First of all, let me explain the solution using the recursive tree. So as you can see here, this recursive tree is not drawn properly. We have when we are trying to get all the amounts, like explore all the possible cases, then first inside for loop first we are minusing. For example, we have an array of 1, 2, 3. First we are minusing 1. Then again that function will get called, then we'll minus 1, then we'll minus 1, then we'll minus 1 until we get any of the base cases. That is if amount will become less than 0 or it will become equal to 0. If it will become equal to 0, this means we have found our amount. Then we'll simply return the coins. It will return the coin here. It will return all the coins here. And we'll finally get our answer. As you can see here, first we are trying to minus the first coin. If we get the answer, we are plusing 1 here. Then we'll returning that. So this means it will return something which will again get returned to the previously called uh, this function. Then again we'll get something here. Then again answer plus 1. Then again it will return something until we reach the last function. And finally the last function will return our answer. So first it will try to minus 1. Then after all the minus 1 are finished, then it will try to do amount minus 1, then minus 2. Then after all minus 2 are finished this side, then it will try 3. And then again it will try 2, 1, 1, 1, 2, 2, 2, 2, 2, 3, 3. This way we'll explore all the possibilities possible, and we are checking at every stage whenever this answer is returning the minimum, what are the minimum number of points. If we have got the minimum number of points previously, then that will remain here. Otherwise, we'll get that new coin. And if the answer is minus 1, then mini will remain int max. In that case, we'll return minus 1, which we are told here to return. So how can we memoize the solution using DP? Like, what's the intuition behind it? As you can see here, we are again and again trying to solve many sub problems. For example, first this loop will go down till the very end, and in this minus 1, minus 1, minus 1, and then it will do minus 2, minus 3. It will explore all the cases here, and we'll get the answer for that. And for again, we are calculating that answer by when we are going through this recursion tree, this part of recursion tree, then we are calculating that answer here again. So instead of calculating those answer again and again, we can simply store those answer. Uh, we can initialize array with minus 2 because there is no value returned with minus 2, so we can easily differentiate if value has been found or not. So we can simply memoize the solution by storing the answer. If amount is this, then we know that answer will be this, so that we don't have to calculate again when we'll go down the recursion. That's why we are storing the answer in array. And if we'll encounter that again, then that amount again, then we have already calculated minimum number of points for that amount. So if array is not equal to minus 2 was the default value. If it's not equal to its default value, this means we have already calculated it. And then we'll return amount, DP amount, which we have calculated earlier. Now let's try to run this code again. We haven't passed the arguments here. So as you can see, our code is running successfully. Let me just submit it. And as you can see, it got accepted. Now let's try to solve it using another approach. In this approach, we are using O of n space plus the O of n recursion stack space. Whenever you call function inside function, then it keeps on adding in the stack like this. For example, when you call a function inside function, then first function will get added up, then the second function will get added up, then when the second function will call the function, then another function will get added up in the stack. So this is also taking space. So we are using vector here as well as recursion stack space. So how can we optimize this further? We can try to solve it with a tabulation method, which means we'll basically create a grid in which we'll store the answer in the array, calculate all the cases, and then return the answer in the end. So let's just do that. We'll by default initialize each and every value with amount plus 1, because by default in every case, whichever coin we are using, by default the amount will be 1. And then as you can see here, base case at 0, dp is 0, so we'll do dp at 0 is equal to 0. You can just simply see this function, try to create exact same solution using this. First, we have to traverse through all the amount and then try to minus if I coin minus I is greater than equal to 0. Then we can say that a valid amount which we can store in dp. Then we can find out the min of dp of I. So dp of I minus coin plus 1. So what have I done here? I'm basically traversing through all the possible amounts, and then all I'm traversing for all the possible amounts. I'm traversing all the possible coins which are there. And if coin minus I greater than 0, which means if after minusing from this coin, sorry, not coin minus I minus coin is greater than equal to 0, which means after minusing amount from this, either it is 0 or greater than that, which means the amount is still left. It is not in negative, which means we can minus the coin. We can store for that amount inside DP. For that amount, either it will be minimum amount, which is already the number of coins which are already stored for that amount, or it will be DP of I minus coin, which means the previous amount, which means the previous number of coins plus 1 here. And then we can finally return in the end if DP of amount is greater than amount, then we can return minus 1. Otherwise, we can return DP of amount. So let me give you a quick revision. First of all, what we did, we traversed through all the possible coins for each and every amount we are getting, and then we are subtracting that coin from the amount. We reach the base case with some coin. This means we have found minimum number of coins for that particular amount. Then we store the minimum number of coins for this amount. So in an array, so that we don't have to calculate that amount again when we reach this case. For example, minimum number of coins to go from 1 to 0 is 1. So if we have calculated here, then if we will reach 1 again somehow with some subtracting with some other coins, then we don't have to again call this function to get 0 and then calculate this because we are storing in dp amount. So we have found then if we have found minimum number of coins for this particular amount, then DP amount will not be -2 because the default value which we initialized it was -2. Then we'll return DP amount simply. In solve tab, what have I done? I have initialized the DP vector with amount greater than what we need so that we can differentiate later that if we have found the amount or not. And for zeroth amount, we need 0 for 0 amount. We can get this from the base case. And then for each and every possible amount, we are traversing to each and every coin and trying to minus that coin from that amount to get the minimum number of coins to reach that amount. And then we are storing it here. As you can see, it's the same condition which is here inside the recursive solution. You can easily make this function just by looking at the recursive solution. It is literally the same thing which I have written here. And then if amount is greater than 0 for the amount which we need, this means that amount is amount plus 1, which means we haven't found the amount, so we'll return -1. Otherwise, we'll return the TP amount calculated. Okay, so let's discuss its time complexity. In the recursive solution, we are traversing through all the possible amounts, and for every amount, we are subtracting each and every coin. So in this case, if we consider amount as n and coins as m, then in this case, time complexity is O of n star m in worst case, and space is O of 2n, which is basically O of n only. And in solve tab also for every amount we are traversing all the coins. So if amount is n and coin is m, then the complexity is O of n star m, and space is just O of n, which is better than the recursive solution. So that was it for this video.
So that's it for this video. If you found this video insightful, don't forget to like, subscribe, and share it with your friend. Do comment down which type of videos do you want in the future. I'll see you guys in the next one.